we want to obtain few properties of Laplace transform. We'll state the following theorem. Let Laplace transform of function f be equals, let's call it capital F of s. Then Laplace transform of new function, which is the old function f multiplied by e to at, equals to Laplace transform f of s minus a. Let's see why that is true. By definition, Laplace transform function f equals to integral 0 to infinity e to negative st f of t dt. Now, if I want to calculate Laplace transform of a new function, Laplace transform of e to at times function f, by definition, that's integral from 0 to infinity e to the negative st times function, which is in our case e to at f of t dt. Now we combine the powers of e, so we're going to get e to the negative st plus at times function f of t dt, integral 0 to infinity. Now we want to rewrite that power of e the same way we have for regular Laplace transform. So what we're going to get is still integral 0 to infinity, still function f of t dt. Now power, we want to have minus in front. We want to have t on outside. Then we will have s minus a. And now if you match it with what we had before, that's essentially the same function as we had before Laplace transform. Only the difference is instead of s, we have s minus a. So that is capital F of s minus a. Now we'll do a few examples on how to use the previous theorem. First example. If we want to find Laplace transform of e to 5t cosine of 3t. Let's see how we're going to progress here. Recall what our theorem says. It says if I want to find Laplace transform of e to at function f, that equals to f of s minus a, where f of s is Laplace transform of function f. So the way we're going to interpret it is the following. So here we're going to find Laplace transform of cosine of 3t, where instead of s we're going to have s minus 5, because that's what the theorem says. It says in order to find Laplace transform of e to atf, what we need to do is change s into s minus a. So in our case we're going to change s into s minus 5 because of e to 5t, and we're going to find Laplace transform of cosine of 3t, and then we'll change it s into s minus 5. Recall what Laplace transform of cosine of 3t, that is going to be s over s squared plus 3 squared. We need to change s into s minus 5, so final answer is s minus 5 over s minus 5 squared plus 9. So that is the Laplace transform of e to 5t cosine of 3t. Let's run one more example on how we're going to use that theorem. Say you want to find Laplace transform e to the 7t times t squared. We're going to find Laplace transform of t squared, and then to take care of e to the 7t, we'll change s to s minus 7. So we're going to get Laplace transform of t squared. Recall what that is. It's 2 factorial over s cubed. Then we need to change s into s minus 7. So we're going to get 2 factorial is 2, and instead of s minus 7 cubed. So that is going to be final answer for Laplace transform of e to the 17.